We're now in Algebra II at 9.2a, and we're going to talk vertical translations, and I have a theorem for you. If you haven't seen the previous 4 videos and you become lost during this video, just click in the description and watch the previous ones to catch up. An alteration of a relation is called a transformation, and if the alteration moves the graph without changing its size or shape and doesn't rotate it, the transformation is called a translation. We can imagine this as an ice skater moving across the ice. So he would be translating, he's sliding along. We can also imagine this as the ice skater remaining in place and the entire skating rink is moving underneath him. So the figure moves across the plane, or the plane moves and the figure stays in the same place. We're going to get the same result, okay? It's just easier to look at it as the figure moving across the plane. So if we had this figure right here, we could either move the figure, okay? I could pull it down and I could move it closer to the origin, okay? It's kind of hard to do with one hand. Or we can just move the entire plane, see? We can move the plane around and the figure can stay in one spot, is what I'm saying. It's just easier to look at this as the figure is moving instead of the plane, okay? So for the relation y equals x squared and y equals x squared plus 1 in their graphs, the graphs will have the same shape except y equals x squared plus 1 is moved up 1 unit because of that plus 1. So the black one gets moved up 1 unit from the origin to 1 on the y, and now it's in the spot of the red one because of that plus 1, that constant. That 1 is a constant that we added. Any equation y equals the function of x with a constant k added will make y equals a function of x plus k. This changes each function value by the same amount k, but makes no change in the shape of the graph. If k is positive, the graph is moved or translated upward. If k is negative, the graph is translated downward. And the equation y equals x squared plus 1 can be written as y minus 1 equals x squared. You know, with the properties of equality, we can add a negative 1 to each side of the equation and get y minus 1 equals x squared. And it's the same thing as y equals x squared plus 1, see? So the transformation is equivalent to replacing y with y minus 1 in the original equation, all right? So here's our theorem. In an equation of a relation, replacing y with y minus k, where k is a constant, translates the graph vertically the distance of the absolute value of k. If k is positive, the translation is upward. If k is negative, the translation is downward. Replacing y by y plus 3 in an equation is the same as replacing it by y minus a negative 3. And in this case, the constant k is a negative 3 and the translation is downward. So if we had y equals x squared minus 3 and we subtracted, not added, if we subtracted a negative 3 from each side of the equation, we would get rid of that negative 3 here, but we'd have y minus a negative 3 on this side, see? It's the same thing as x squared minus 3. That's a downward translation because we have minus 3 there, see? On the y side, we get a double negative. See that? So, if we replace y by y minus 5, the constant is 5, and the translation is upward. So if we had x squared plus 5 on this side, and we added a negative 5 to each side, we get y minus 5 equals x squared. Well, that's a plus 5 on the x side. That's an upward translation, see? On the y side, it's a minus 5, okay? For the graph y equals the absolute value of x, we can draw the graph y equals the absolute value of x minus 2 by translating. So in this graph, we had y equals the absolute value of x in black, and it translated, because of this minus 2 constant, it translated 1, 2 downward. And the whole thing just slid down 2 units. We can see that y equals the absolute value of x minus 2 is equivalent to y plus 2 equals the absolute value of x. So we can add the new equation. We can get the new equation by replacing y with y minus a negative 2. And by our theorem, our translation is downward by 2 units. If we have y equals the absolute value of negative 2 and we added 2 to each side, we get a 0 pair here, right? And this is a minus 2, so that's a downward translation. But on this side, we get y plus 2 equals the absolute value of x. See that? How we did that? Because we added 2 to each side. If we have y equals the absolute value of a negative x and we subtract a negative 2 from each side, that creates a 0 pair there, and that was a downward translation. But on this side, we get y minus a negative 2 equals x. When we distribute that in, we would get y plus 2, wouldn't we? It's the same thing as y plus 2. All right? Our next video is 9.2b, and we're going to talk about horizontal translations. This was vertical. I'm going to add this to the Algebra II playlist so you can study with it. There's going to be a link to last year's Algebra I video, 12.2, when we talked about functions and graphs. The previous 4 videos for this chapter 9 are going to be in this description as links. And there's also going to be a link to grade 8 math, 9.4a. We talked about translations back in 8th grade. So if that would be an easier video for you to watch and then come back and watch this one, maybe that might help you, okay? It's been a long time. Maybe you don't remember, all right? That's no big deal. We all forget stuff. So I hope this was helpful. And hit the like button if it was. I really appreciate it. Don't forget you can support me on patreon.com and become a monthly patron. You can also go to YouTube fan funding for just $1 or $2. That would help me out, and it would help out feeding my dogs and taking them to the vet. And I hope you have a great day. Bye.